Hi class, today we're going to be using our textbooks. We're going to use 4 different pages of our textbook. So let's jump right into it. The first page we're going to look at, page 901. Go to 901 in your textbook. Page 901 consists of translations, okay? So it says triangle ABC is translated 5 units to the right and 1 unit down. Okay, so on your paper, we're going to graph and label the image ABC. What is M angle A? So that's what we're going to look at today. When you're solving for translations within the graphs, you've got to move your units to the left, to the right, up, or down, okay? It's all going to depend which way you go depending on the information they give you. Translation preserves the angles measurement, okay? So you have to move the translation. You have to conduct the translation first to preserve the angle measurements. If you have your image over here and you're going to translate it and move it over here, are your angles going to stay the same? Yeah. The location is going to move, but the angles are going to stay the same. So they're asking, if you have M angle A, what will the angle be? What will the degree be? Well, it's going to be 30. That's right, because it already was 30. So we're going to keep it at 30. That's not going to change. The location on your graph is going to change. The angle is going to stay the same. So show me on your graph for this try it question. Really good job, guys. Okay, turn your pages over a few to page 905. Good job. Okay, we're going to go to the try it at the very bottom. It's easy. Describe the rotation that maps triangle FGH to triangle FGH. Okay, you're looking at it on yours, right? Okay, perfect. Look at the rotation. We have one FGH here and the other over here. Just like on your page, look at your textbook. So the best course of action is to determine if there's a 90 degree clockwise rotation first, okay? We want to know if it does a 90 degree rotation, okay? If there was a 270 degree counterclockwise rotation on its origin, then it would be considered equal to if there was a 90 degree clockwise rotation. So you need to rotate each angle or letter, however you want to word it, to determine how it rotates. Okay, so you've got letter F. Find letter F on the one on your left. Okay, it's at -4, 0. You're going to rotate it to 0.04. So your first ordered pair for F is -4, 0. You're going to rotate it to 0.4. Very good. Okay, now let's look at point G. Point G rotates from its starting point, which is -2, 2. Now rotate that point to 2, -2. Very good. Make sure you're labeling these as you go. Okay, let's look at point H. Point H rotates from -2, 0 to 0, -2. Okay, now look at your rotation. These coordinates match their originals. Therefore, the rotation is a 90 degree clockwise rotation. Good job, guys. Let's move on to the next. Okay, we're at page 924. Let's look at 924. Polygon ABCDE is reflected across the line H equals -2. They want us to graph this, and then is M angle A equal to M angle A? Let's look into it. In order to solve this, first we have to reflect every vertex of the polygon across the line X equals -2. So for the point A, -1, 4 will reflect to be -3, 4. For the original point B, which is located at negative 1, 2, will reflect to be negative 3, 2. Do you see the pattern? The x is changing in the original, okay? C, 1, 2 is the ordered pair. X is 1, 2 is y. We're going to reflect it to be negative 5, negative 2. Point D is on the origin, 0, 0. It's going to be reflected to negative 4, 0. For the original point E, negative 3, 0 will reflect to be negative 1, 0. Angle A's will be considered equal because remember, we're not changing the angle. We're just moving it, okay? The angles are always going to be preserved. They're always going to be kept the same. We're not changing the angles. We're changing the location, okay? Okay, make sure you have all that down. Last one. Okay, last one, guys. Page 939. Okay, guys, we're on page 939 from the try it section. We're going to look at where it says a dilation maps point L, the ordered pair 3, 6, to its image L to the ordered pair 2, 4. Complete the dilation of the figure. What is the scale factor? What is the length? Okay, make sure you're looking at your page. Okay, so when finding the scale factor, you will first need to know how to find the scale factor, right? To find the scale factor of the dilation K, you will divide the coordinates of the image by the coordinates of the original, okay? The coordinates of the dilated image can be found by multiplying the coordinates of the original point times the scale factor. It's a lot of words, it's a lot of movement, but we got this. After you do all that, then we have to use the distance equation, okay? So let's just break it down and do it. We got this. The scale factor of K is 2/3, okay? We found it, we got it, that's it. We're going to take the M coordinates and times them by 3. So 3 times the M coordinates times 2/3 equals 2. Okay, so we have a new ordered pair, which is the same ordered pair, but it's a new 2, 0. 2 being x, 0 being y. The N coordinates are 6 times 2/3, which equals 4, making the ordered pair 4, 0. The length of MN is 2. We solved that by using the distance formula. So x squared minus x1, I'm sorry, not x squared, it's x2 minus x1 plus y2 minus y1. All of that is squared. So in the scheme of things, after you do all your equations and all your calculations, the scale factor is 2/3 and the length of MN is 2. You guys did so good and follow along so well. All right, let's keep going. Bye.